How can you make a singleton in Python? A singleton class is a class that only ever allows one instance of itself to be created. None objects in Python are singletons. The class of none is none type. And if we try to call this class, we'll get back an instance of that class. But every instance of the none type class is identical to every other instance of the none type class. There's only one instance of none type in Python, and it's none. How can we make our own singleton class in Python? We have a class here that helps us keep track of events in our application. We'd like to share just one instance of this class for our whole Python process. To do that, we could make a singleton class, which only allows one instance of itself to be created. We can make a singleton class by customizing our class to have a custom constructor method. Python's dunder init method is called the initializer method. By the time the dunder init method gets called, our class instance has already been constructed. That's what the self argument is. The dunder new method is the constructor method. Its job is to do the actual work of constructing and then returning a new instance of our class. Our constructor method in our case always returns the same instance of our class. So if it doesn't have a class instance yet, it calls its parent class's constructor, which the parent class of every class in Python by default is object. And if we do already have a class instance, we just return it. So we have one instance that's shared between every instance of our class, meaning if we call our class, we'll get back a new instance. But if we call our class a second time, we'll get back the same exact instance. Every instance of our class is the same. Now, this does work, but it might seem a little bit misleading to someone using this class that when they call it, they'll only ever get one instance of it. This singleton pattern really doesn't make sense in Python in its purest form. Instead, it usually makes more sense to make a single instance of a class and then assign that instance to a global variable in our module. So here we've actually renamed our class to _event tracker, which isn't strictly necessary, but it does let people know that you're not actually meant to use the class directly. You're only ever meant to interact with this one instance. So then when using our class, we wouldn't actually interact with the class directly. We would import and use just that single class instance. Now, if there's not actually any reason to ever have two instances of your class, you might consider not making a class at all, and instead just using the global state within your module. So here we've made an events module that does the same thing as our events module before, but we don't have a class. Instead, we've taken the state and the functionality that was within that class, and we've put it at the module level. So to use this module, instead of saying events.tracker.track like we would have done before, we just say events.track. We're calling our track function at the module level. Now this works for the same reason that making a global object works. Modules in Python act like singletons. When you import a module in Python, Python will run the code within that module and create a new module object. But if we import the same module again, Python will actually give us back the exact same module object. Meaning, if we were to change some of the global state within one of these module objects, it would change the global state the same way within every other module object for the same module. Because for each module, there is only one module object in Python. So if you need to share global state in Python, it's often simplest to just use the global variables within a module. The classic singleton design pattern doesn't always make a lot of sense in Python. Singletons are most often used for sharing global state. And in Python, if you need to share some global state, you can often just use a module object, because in Python, modules are singletons.